Today we're diving into the incredible and, for a long time, forgotten story of Jean Bartik, one of the world's very first computer programmers and an absolute pioneer of the digital age.
So, when you think of the first computer programmers, who pops into your head? You know, the image we usually have is probably pretty different from the reality back in the 1940s. The story of the ENIAC computer and the amazing women who programmed it is about to challenge everything you think you know.
Just try to imagine this for a second. You've been hired for a top-secret project during World War II. You know you're working on some kind of revolutionary new machine, but you're not even allowed to see it. This quote from Jean Bartik just puts you right there. She and 5 other women were basically handed a pile of wiring diagrams and told, okay, figure out how to program this thing that's going to change the world. A machine that, barely even existed yet outside of those blueprints.
So how in the world did a young woman from rural Missouri find herself right at the heart of the computer revolution? Well, to get that, we've got to go back to the very beginning of her story.
To really get her journey, you have to picture her world. We're talking 1945. A gallon of gas was 15 cents. Minimum wage was 40 cents an hour. And in this world, for most women graduating from Jean's college, which was literally a teacher's college, the path was pretty much set. You were expected to teach. But Jean, she wanted something completely different.
She was crystal clear about it. The conventional path just wasn't for her. She had a math degree, a super sharp mind, and this deep craving for adventure. She was looking for a way out, a chance to be part of something, bigger.
And that ticket? It came in the form of a simple job posting. The Army needed women with math degrees to work at the University of Pennsylvania as computers. And back then, a computer wasn't a machine. It was a person who did complex math by hand. For Jean, this wasn't just a job. This was it. This was the adventure she was waiting for. And get this, she was on a train to Philadelphia the very next night.
So she arrives in Philadelphia and is almost immediately picked for a brand new, top-secret project, programming the ENIAC, the world's first all-electronic digital computer. The challenge that she and her new team were facing was just immense.
Because programming in 1945 was something totally physical. There was no keyboard, no screen, not a single line of code. Programmers were basically hardware engineers, turning math problems into this dizzying maze of wires and switches. And that physical, manual work was probably a big reason it was so undervalued. It was seen as, clerical work, not the deep, intellectual puzzle-solving it really was.
Just check out their process. First, they had to take these super complex mathematical equations, like for a missile's flight path. Then, they had to break it all down into tiny little steps the machine could actually handle. After that, they had to physically plug in hundreds of cables and set thousands of switches to wire that logic into the machine. And if one little thing went wrong, debugging meant literally hunting for one bad vacuum tube out of 18,000. Unbelievable.
But here's the thing, they weren't alone. The 6 women, Jean, Betty Snyder, Kay McNulty, Marlon Westcoff, Ruth Lichterman, and Fran Billis, they became this incredible team. They had to lean on each other, basically inventing a new science from scratch. And they had a key ally in John Mockley, one of ENIAC's lead engineers. Jean called him a marvelous teacher because he actually took the time to explain how the nuts and bolts of the machine worked.
Okay, so all of this work leads up to the machine's first public demonstration in February 1946. The stakes could not have been higher. They had to prove to the entire world that this giant, ridiculously expensive machine actually did what it was supposed to do. The night before the big show, they hit an absolute disaster. Their main program, the trajectory calculation, it ran perfectly, but it wouldn't stop. So when the missile in the simulation hit the ground, ENIAC just kept on calculating, basically digging a virtual hole straight through the Earth. With the world's press and scientists showing up in just a few hours, they were completely out of time.
And this is where that incredible teamwork and, just individual genius saved the day. Jean said this about our friend Betty Snyder. They all went home that night, totally defeated. But Betty's brain just kept churning. She walked in the next morning, went right to a specific panel, flipped a single switch that she'd realized was wrong, and just like that, problem solved.
The demonstration was a breathtaking success. And the proof? It all came down to one single powerful number, 20 seconds.
So what does 20 seconds actually mean? Well, a trajectory calculation that took a skilled person with a desk calculator 40 hours to finish, the ENIAC did it in 20 seconds. It was literally faster than the speeding artillery shell it was tracking. Think about that for a second. The digital age had just been born.
So, what happened after this massive achievement? Well, for the women who made it happen, the path forward got complicated. And their role in history started getting erased almost right away.
That very night, there was a huge celebratory dinner for all the bigwigs and the lead engineers who worked on the project. And the 6 women who had programmed the machine and literally saved the demonstration? Yeah, they weren't invited. It was the very first sign that their contribution was being seen as somehow less important.
And in the years that followed, as the history of computing was being written, the story always focused on the male hardware engineers and administrators. The men on the left, they became famous. The women on the right, the ones who actually made the machine performance miracles, they were treated like a footnote, if they were even mentioned at all.
Herman Goldstein, he was the Army officer in charge of the whole project, wrote a really influential book on the history of computers. In it, he claimed that he and his wife were the ones who programmed that big demonstration trajectory. Jean Bartik's response, years later, was simple. It was direct. She said he lied.
So for decades, their story was just lost. But history is a living thing, right? And thanks to some really dedicated researchers, the record was finally set straight.
This timeline just shows you how long their story stayed buried. For 40 years, their legacy was nearly invisible. Then, in 1986, a researcher named Kathy Kleiman started digging. Her work eventually led to major articles and public recognition. It took half a century, but the ENIAC programmers finally started getting the credit they'd earned all along. Jean Bartik and her team weren't just computers. They were programmers, they were pioneers, and they were the brilliant minds who literally breathed life into the dawn of the digital age.
And that really makes you wonder, doesn't it? It took 50 years to uncover this story, a story that was hiding in plain sight the whole time. So the question we're left with is this: whose stories are still out there, just waiting for someone to start asking the right questions?